Okay, so we are doing 3.3 systems by graphing. So remember, okay, we started with 3.1, which was substitution. Then we went to 3.2, which was elimination. Last Thursday, we graphed ordered pairs and we graphed lines. Today, we're going to solve our systems by graphing. Okay, so we're going to solve our systems by graphing. Now, a few things that we need to know. First of all, the whole point of systems by graphing is to find the intersection point. Okay, so we're wanting to know where two lines intersect. So if I have two lines on a graph, the solution of the system is that XY point where they intersect. Okay? It's that XY point where they intersect. Now, sometimes though, we have two graphs that never intersect. What do you think we call them? Do they intersect?
I call them no.
I call them no solutions also. Okay, if they never intersect, it is a no solution. Now, sometimes though, they're the same exact line. Okay, what do you think we call them if they're the same exact line?
I call them infinity.
Infinity or infinite many solutions. Good. Okay, so we'll have three different types of answers today. We'll have an ordered pair, XY, a no solution, or a mini solution. Just like we've had for substitution and elimination. Nothing new, just the method. Now, in order for us to graph today, remember it must be in slope-intercept form. We did that Thursday. So we're going to do that again today. Now, remember that slope-intercept form is y equals mx plus b. Remember, our slope is the m, and our y-intercept is the b. Okay? So we have our slope-intercept form. They have to be in slope-intercept form, so if they're not in slope-intercept form, I have to rewrite them. Okay, these down here are in slope-intercept form, so I could graph those. Now, we're just going to do a couple of examples, 2 or 3 examples, where we graph these and we determine what our solutions are. Okay, so it's not crazy difficult, but we are going to look at a few examples.
I'm not done.
Okay, I'll wait on you.
Yeah.
I'm kind of slow today.
It's all right.
Take hold. I'm kind of short. And yeah. Thank you.
You don't have to write these examples down here if you don't want to, because I wrote slope-intercept form right there. So.
Oh, that's why I call them equals b.
Yeah.
There you go. I'll just put y equals b.
Okay.
That's fine.
That's fine for you. Got it all down?
Yeah.
Yeah. Okay.
There's times I've just said mxtb because you know the plus sign.
Yes.
Oh, I already know.
So, have you watched One Punch Man? Have you seen Rocky? Not yet. You've never seen Rocky? No, I've
Got it?
seen parts.
All right. So let's look at a couple of examples. Okay. First of all, I have these two equations here.
Yes, you do.
Y equals x plus 3 and y equals 5x minus 1. Now, I'm going to separate them so that I can identify my slope and my y-intercept. And then we'll graph them. And I'm going to do it in a different color so that you can see the two different lines. You don't have to do that today, though.
What if I have 2 different colors?
You can use 2 different colors if you would like.
I can't see that. Crazy.
Okay, So let's look at the top equation. So I need to determine what my slope and what my y-intercept is. Okay? So Cole, what is my slope here?
On which one?
On the top one.
1/1.
1/1. Good. Remember, if there is nothing in front of the x, I imagine it's a 1. And I write 1/1 because I have to have a fraction. Okay? Aliana, what would my y-intercept be?
For which one?
For the top one, sorry.
3.
3. Good. It's the number there at the end. Okay? Now, so let's look at the second one.
My turn.
Ryle, what would the slope be?
5.
5. How do I write it as a fraction?
5/1.
5/1. Pfeiffer, what about my y-intercept? What would my y-intercept be? -1. Good. Now, before we graph these, I want to see what each one does. So the slope, remember that slope is rise over run? So if the top is a 1, I go up 1. If the bottom is a 1, I go right 1. Okay? Rise over run. The 3 tells me up 3, but on the y-axis. Down here, the 5 tells me up 5. And the 1 tells me right 1. And then the -1 tells me down 1. So I'm going to try to put my coordinate plane in here, and we'll see if I can get it on to do correctly. Yeah. Okay, so I'm going to graph these two lines. So the very first one that I'm going to graph is the one that I've written up here in black ink. I graph the y-intercept first. So I go up 3. Cole, let Pfeiffer pay attention because he'll have questions. So I'm going to go up 3. And I'm going to have a dot, and that's the wrong color.
Wait,
Hold on. Hold on.
we're allowed to use this graph here.
Yes, you are. Okay, so up 3. Now, my slope tells me up 1, right 1. Up 1, right 1. Up 1, right 1. Or I could go down left. I could do the exact opposite. Down 1 left. Down 1 left. Now, it's going to be important today that your lines are fairly straight. So I've given you a ruler so that you can make straight lines, because you're going to have to find that intersection point. So there's my first line. When I do my second line, where do I start, Cole?
-1.
Which is how?
It's down.
Down 1. Good. And then when I go down 1, then I'm going to use my slope. Whoops. Which is up 5. 1, 2, 3, 4, 5. Right 1.
Same line.
1, 2, 3, 4, 5. It's not the same line.
I was almost right.
Sure.
Okay? Yeah, we know my lines aren't straight. So
You
now,
might have to be exactly straight or just as straight as yours.
no, they need to be straighter.
Okay.
So our solution is this point of intersection, which is over 1, 1, 2, 3, 4 up. So 1, 4 is my point of intersection. Remember that the x value goes right and left.
Oh.
So if I start in the middle, I go over 1, which gives me my 1, up 4, which gives me my 4.
Used
Now you have a
to,
triangle.
Okay? Yeah.
used to in algebra
0, 0,
1,
0.
we
This
would
is algebra 2.
Huh?
This is algebra 2, not
I know.
algebra 1.
But like in algebra 1 or pre-algebra, I think, I can't remember. We always did the y, then the x.
Always the x, then the y.
Huh.
Yeah. Always the x, then the y. Okay, let's look at another one. Let's look at this one right here. So I have x plus y equals 1
Wait.
and x plus y equals 4. Okay? So when I look at this one, Pfeiffer, are my y's by themselves?
No.
Are the y's by themselves, or do they have something with them on the same side? They've got the x with them, right? So I need to get this in slope-intercept form. So I'm going to look at the first one. X plus y equals 1. How do I move a positive x?
Negative.
You subtract it. Good. Negative x. So I'm going to write it with the x first. So y equals negative, I'm going to put a 1 there, just so I know, equals 1.
Plus 1.
Plus 1, right. Okay, so I need to know my slope and I need to know my y-intercept. So Rex, what would my slope be?
Negative 1 over 1.
Good, negative 1 over 1. And Pfeiffer, what's my y-intercept?
1.
1, good. Okay, that's all right. So there's my first line. Let's look at my second line. I have x plus y equals 4. Cole, is it in slope-intercept form?
No.
What do I need to do?
Subtract x.
Subtract the x. So now I have y equals, I'm going to say negative 1x plus 4. So Aliana, on this equation, what's my slope?
On this, 1, negative 1.
Negative 1. How do I write it as a fraction?
Negative 1 over 1.
Good. And Pfeiffer, what's my y-intercept?
4.
4. Good. So now I have 2 lines that I can graph again. Okay, so I'm going to graph the first line. All right. So I do the y-intercept first. It is a positive 1. What does that mean?
It's 1.
Go up 1, right? So I go up, 1. And then my slope is a negative 1 over 1. So do I go up or down first?
So you go
Down,
to the right.
and then to the right. Good. Down, right.
Sure.
Down, right. I could do the opposite.
Left up, left up.
And I'm going to draw my line here.
Very, very straight.
Very, very.
See, that was straighter than the last one.
Yeah,
I know. Sometimes I'm really good, sometimes I'm really bad.
So now
Okay.
this one you start at 4.
So this one we start at 4, correct. So I go 1, 2, 3, 4 up,
Down went with your, that line went with
Down.
the curve of your body.
right, down, right, down,
then
right.
you have
Uh-oh.
solution.
So I do have no solutions, and why?
Oh, because it never touches.
Because it never crosses.
Oh,
Good. Okay? So you guys see what we're doing today?
Big bite.
Not difficult, correct?
no,
Big
it's difficult.
bite. I mean,
Not difficult.
let me do move your board. Well, that was amazing.
When did you